They bring me learning about ellipses. E-L-L-I-P-S-E, ellipses.
Teacher, what's an ellipse?
An ellipse is the set of all points x, y, the sum of whose distances from two distinct fixed points called foci is constant. So it's like this shape.
Well, that's a really complicated definition.
But it doesn't have to be, Anita. See, ellipse is really, let's say you take a cone, right? Since we're learning about conic sections. You know, a cone, you know, it's kind of like a hat. And then...
Looks like a party hat.
Yeah, that's pretty good. So you're going to take a slice sideways. Let's say you really hate party hats, okay? So you take a slice of it sideways, you know. The difference between an ellipse and a circle, right? Or, okay, well, a much rounder circle, is that a circle has a slice that goes like this. It's all points are equal in a circle, but whereas an ellipse, some points are farther away. It's around. It's 2 points. All points are same distance from 2 points instead. Okay.
Okay.
Graph the ellipse x plus 5 over 4 plus y plus 2 squared over 16. First, we want to figure out if it's a horizontal major axis or vertical major axis. Horizontal major axis simply means it's going to be longer across the x-axis, and a vertical major axis means it's going to be longer on the y-axis. Okay. The way we figure this out is we look at the denominator. Okay. We see that 16 is clearly larger than 4, and this is under y, so this means it will be a vertical major axis. Now let's look at the standard form of an ellipse. Our equation is x minus h squared over b squared plus y minus k squared over a squared. If we go back to our original, we know that our center, hk, is going to be -5 and -2. And the distance to our vertices is going to be 4 and 2. I think I got it right. Oops. Okay, hold up. I'm having computer issues.
Technical difficulties.
Oh. Okay, so let's, okay, well, ignore the fact I graphed this. Let's make a new graph. Well, class in session, I asked you to put your phones away, please.
Sorry, sir.
So our center is at -5, -2, okay? This doesn't have to be like an amazing graph. So, what did we say earlier? What major axis was it, Anita?
What?
Was it horizontal or vertical?
Oh, horizontal. Right?
It's actually vertical, you know, but thanks for participating. Anyways, since we know it's going to be like this shape, right? It's going to be 4 up, 1, 2, 3, 4, and 4 down, 1, 2, 3, 4. And same thing for vertical, or no, not the same thing. It'll be 2 across for our vertical. Oh, okay, well, I'm really bad at drawing, but you get the idea.
And what's A and B?
Oh yeah, sorry I
On
didn't
an
explain it
ellipse?
very well. So, A is like basically, in a circle this would be the radius, okay? This distance is 4 between our center, HK, and this side. And the same thing with 2, it's the distance between the center and the vertex. So that's going to be 2. You get it now?
Yes, thank
Alright.
you.
Another example, it's going to be, oh well, you can see that, never mind. I don't need to draw it again. Example 2. This time we know it's going to be horizontal major axis since we have a larger denominator under our x term. Let's take a look at our standard equation for horizontal. Okay. x minus h over a squared plus y minus k squared over b squared. We compare that to our original. Okay. So it looks like our h and k is going to be 5 and 3. Our a is going to be 5, and our b is going to equal 4. If we take a moment to graph this, 1, 2, 3, 4, 5, 1, 2, 3, that's our hk. I said horizontal earlier, right, Anita?
Yes.
Okay. So
because
1,
the
2.
bigger number is under x.
That's correct. Good job.
Thank you.
And our vertical is going to be 4. 1, 2, 3, 4. Wow, amazing. Imagine this is an amazingly drawn ellipse. Okay. Do you have any questions?
So the numbers under the denominators like defines the shape of the ellipse, right? Like.
Yeah, let's say we have like something really, really big here. Then we're gonna have like an amazingly long, amazingly long ellipse.
Okay. That's all the questions I have.
Okay.
And I'm sorry, I have to substitute. The teacher had a stroke, so yeah. Okay. Anyways, we're gonna do another example. So this is example 3. It's on the bottom right here. So we're gonna find the foci of this ellipse. So you have 9x squared plus y squared plus 18x plus 10y minus 2 equals 0. And then you would first combine the like terms, put the like terms together, and then move this to the other side. And then you would factor it out. So you would get 9, and then x squared plus 2x plus blank because you have to complete the square, plus y squared plus 10 y plus blank equals 2, and then you would complete the square in x and y. So you would get 9x squared plus 2x plus, so to complete the square you would get the you get 2 and divide that by half and then square what is it? Square it. So you would get this would be 1, and then plus y squared plus 10y plus 25, because 10 divided by 2 is 5, and then you square that, and then it's 25. And then equals 2, and then you can't forget to add this 2 to the other side. So you would add 9 and 25 to both sides, and that. Oh, sorry. And then you would simplify this to 9, and then x plus 1 squared plus y plus 5 squared equals 36. And then you would divide 36 to both sides to get 1 on the right side. And then you would get the standard form, which is x plus 1 squared over 4 plus y plus 5 squared over 36 equals 1. And then because the y term has a larger denominator, this would be a vertical major axis. And then from this standard equation, you know that the center is -1 and -5. To find the distance c of the foci from the center, you use the equation c squared equals a squared minus b squared. And then you would know that a squared equals 36, and then b squared would be 4. Then you would plug in a and b to solve for c. So you get c squared equals 36 minus 4 equals 32. And then you simplify that, and then you get 4 root 2. And then finally, you add c to the y coordinate to find the focus, and then you would get the following answer. -1, comma, -5 plus 4 root 2, and -1, comma, -5 minus 4 root 2. And then that would be your focus of the equation.